Okay, good morning class. So today we're looking at, you guys had homework. There was a shortened lesson because you wrote a test again. You guys had some homework, correct? The homework was on exercise 2.17. Not so. We did example 2 or 3 yesterday. Example? The speed, distance, time graph is example 3. So basically we came to the end of that chapter, that exercise 2.17. Not so. But I'm sure there's some problems. Is there problems? Okay, so we will leave that for Monday. Okay? I just need to wrap up the inequalities section. Well, let's just mark. Let's do it properly. Otherwise, we're leaving too many things unanswered. Okay. So, firstly, you guys had homework. We're going to mark the homework instead. Okay. We had homework. The homework was exercise 8, I think it was, no? 8 from the platinum, not platinum, from the Mine Action series. We were doing the nature of the roots there, not so. This year I asked you to do 4 till 11, not so. Was there any problems with this exercise? Number 4, 5, 6, okay. Walaikum salam. Walaikum salam, was it? Alhamdulillah. Mubarak inshallah. This is exercise, what's this? 8. On page. What page is that on? To the Mine Action 6. Okay. You don't know? 36. 46. 36. Okay, so number 6, anything else? Number 7? Number 8? 8. 7. 9? 8? 9? 10? 10? 11? Did I give you 11 to do? So 11 is fine. 12? 13. Okay. So 6, 7 and 10. Now the question says, show that the roots of the equation r plus 1 whole squared plus 4x plus 1 equals r are real for all real values of r. So firstly I need to bring that over to get it in the form of ax squared plus bx plus c. Okay, so it's going to be r plus 1 x squared plus 4x plus 1 minus r is equal to 0. So my a value of course is r plus 1. My b value is 4 and my c value is 1 minus r. So delta is going to be b squared minus 4ac. Your b value is going to be 4 squared minus 4. Your a value is r plus 1. Your c value is 1 minus r. So as you can see, this is conjugate pair. So I multiply that out. So it's going to be 4 squared, which is 16, minus 4 into 1 minus r squared. We multiply that out, I'm going to get 16 minus 4 plus 4r squared, which is simply 4r squared plus 12. So that the sum we just, I think we did the sum already. So why are you, who's asking this question now? Sorry? Did we do this question? We did. So So you're just calling out numbers for me to do. So as you can see, I explained with regards to the parabola. So since delta has a minimum value of 12, therefore roots will always be, so roots are always real. Okay. Number 7. Number 7. For which values of k will the equation x squared minus 5x minus k have, in the first case, equal roots? Okay, so firstly, what's my a value here? 1. Your b value is negative 5 and your c is negative k. All of these are dependent on delta, which is b squared minus 4ac. In this case, it's going to be b, which is negative 5 squared, minus 4a is 1 and c is negative 5, negative k, which gives us 25 minus 4k. In the first case, I want to know for equal roots. For equal roots, delta is equal to 0. So in other words, 25 minus 4k is equal to 0. So negative 4k is equal to negative 25. So k is going to be 25 over 4. Okay? B, I want to know for real roots. Real roots? What do we know about real roots? Delta is greater than or equal to 0. So delta is 25 minus 4k being greater or equal to 0. So negative 4k greater than or equal to negative 25. Divide by negative 25 both sides. And negative 4 both sides. The inequality swap and you divide by negative. So it's going to be 25 over 4. As long as k is less than or equal to 25 over 4, your roots will always be real. And the last one, C, if the roots are non-real, what do we know about non-real roots? Delta is less than 0. Delta is negative. So it's going to be 25 minus 4k is less than 0. Negative 4k is less than negative 25. K is then greater than 25 over 4. Okay. Then the last one, which is number 10. As you can see, we spent a lot of time on this here. It's very important in grade 11 to know this. In number 10, for which value or values of k will the equation have equal roots? All roots are dependent on delta, where you discriminate. So as you can see here, there's your x's. So I must get it in standard form of ax squared plus bx plus c. We already know what your a value is 1. However, we look there, we take out x as a common factor. Although 2 is also common, I'm not worried about taking out 2 as a common factor. I just take out x because whatever the coefficient of x is, that's your value of b for the of the formula. So my a value of course is 1, my b value is 2k plus 4, and my c value is going to be 9k. Delta is equal to b squared minus 4ac, which is 2k plus 4, all squared minus 4, a is 1 and c is 9k. Which is simply, binomial squared is 4k squared, that times 2 is 80, 16k plus 16 minus 36k. Which now gives us 4k squared minus, what is 16 minus 36? Is, says 20. K plus 16. Not so? So So what's the question? The question is for have equal roots. What do we know about equal roots? Equal roots. What do we know? Delta equal to 0. So we got 4k squared minus 20k plus 16 is equal to 0. From here, you can divide by 4. And give you k squared minus 5k plus 4 is equal to 0. Trinomial, k and k, 1 and 4. So k is then equal to 1 or k is equal to 4. If we had said for non-real roots, then you would have said k is less than, delta is less than 0. If we had said for real roots, delta is equal to delta is greater than or equal to 0. Okay. So that basically brings us to the end of the nature of roots. As I indicated before, very important concept to understand. Okay. We will exercise 2.17. You had a few sums that you had for homework, which was number 4, 5, 10 and 15. Inclusive of that was 9 and 13. Correct? Alright. So what was the issues here? Sorry? 5 and 10. Okay, anything else? So this is exercise 2.17. Number 5, no? And 10. Okay, so it's going to cut 5 first and then afterwards do 10. So here, number 5, you are told that Tabo is a minibus taxi driver. Is a regular trip is a distance? Okay, so this is a speed distance time question. Not so? So we draw. I'm going to make it smaller. So we know DST. DST. So Tabo is a mini taxi driver, minibus taxi driver. His regular trip is a distance of 30 kilometers on the highway between Soweto to Johannesburg. Okay? So his return trip, of course, Johannesburg to Soweto. The speed limit on the highway is 120 kilometers per hour. Is he doing that speed? No. That is the speed limit. The morning traffic slow him down and his average speed is X kilometers per hour less than the speed limit. So what speed is he doing? He's doing, okay, this is 30 here firstly. What speed is he doing? 30 kilometers, X kilometers less than 120. So if the speed limit is 120 and he was doing 50 kilometers slower, then what speed was he doing? 70. If he was doing 20 kilometers slower, what speed was he doing? 100. And how do we get that? We say 120 minus whatever value lies here. So in this case, it's going to be 120 minus X. Okay. The morning traffic slows him down and his average speed is X kilometers per hour slower. Answer the following questions. What is the type of speed in the morning in terms of X if he travels at a constant speed? So the S1 is in the morning, and that's going to be 120 minus X. Not so. In the afternoon, I'm looking at B now, in the afternoon, he's able to travel 20 kilometers faster. So his current speed is 120 minus X. -X, but faster. So I add 20. So he's doing 140 minus X in the afternoon. Not so? There's 140 minus X in the afternoon. So now, what is his speed in terms of X? 140 minus X. That is, speed 2 is 140 minus X. Now, the time taken here is what? What's the time taken? How do you work out T? It's distance over time. So it's 30 over 120 minus X. T2 is going to be again 30 over time, which is 140 minus X. Okay. So the question says, Tabu, now see, Tabu completes the afternoon trip in 10 minutes less. So if I subtract the two values, I must get 10 minutes. The difference between the trip in the morning and the trip in the afternoon is 10 minutes. Not so? Calculate how fast he travels in the afternoon. So in other words, we must calculate your T2. Not so? So which trip is faster, the afternoon or the morning? Which one is bigger in terms of time? The morning. Not so? So we always take the bigger one minus the smaller one. So it's going to be 30 over 120 minus X minus 30 over 140 minus X equals 10 minutes. Since this is kilometers per hour, it's going to be 10 over 60. Okay. I'll work this one out already. So that basically gives us 30 times 60 into 140 minus X minus 30 times 60 into 120 minus X equals 10 into 120 minus X into 140 minus X. Okay. Multiply that whole story out, simplify, you should get 0 is equal to 10x squared minus 2600x plus 132 000. You plug that in your quadratic formula, you should get one of two values. X is equal to 69,172 kilometers per hour, slower, that is your reduced speed, or a value of, that one doesn't work. What was this value here? Sorry? Nobody got the summary. $190 kilometers. 190,83. 190,83. It can't be that one, because X is the speed below the speed limit. So if you say 120 minus 190,83 is going to give you negative whatever, negative 70 there around. Yes.
So is the
quadratic formula. Yeah. That's substituting that in the quadratic formula. Okay. So, did we answer the question? No. What's the question? The question was, how fast is doing, question is, calculate how fast he travels in the afternoon. So in other words, you want to work out S2, speed 2. Not so? So S2, speed in the afternoon, is represented as 140 minus x. Not so? So therefore, the speed in the afternoon is going to be 140 minus 69,142, which gives me a speed of 70,8 kilometers per hour. Okay. Let's look at number 10 quickly. Another speed, distance and time question. So we are told that the train travels 90 kilometers as you see, whenever I go speed, distance, time, I draw the following. Okay? And I remind myself of the formula, DST. Okay? So you put the DST. Right. The train travels 90 kilometers with a full load between two stations in the Karoo. Okay? So that is 2, and this is the return. Okay? To the station, and that's returning. 90 kilometers is the distance, of course. On the return journey, the train travels empty and is able to travel 30 kilometers per hour faster. So what do we say? We say let the initial speed, or S1, be x. So if S1 is x, what is then the second speed, or the return speed? It's going to be 30 kilometers faster. So it's going to be x plus 30. The previous one I didn't need to introduce the x. Why? Because why? They told us about x. Here we bring an x into the story. That is why we have to say let S1 be x. Okay. 30 kilometers faster. Right? And completed the journey in 30 minutes less time. So the difference between the two is 30 minutes, which is 30 over 60. Calculate the speed of the loaded train and the time between the two stations when the train is loaded. So, train travels 9 kilometers with the full load, so this is going to be the one with the load. Not so. So in other words, I'm calculating x and I'm calculating T1. Not so. So what is T1 equal to, people? How do you work out time? It's distance over speed. So it's going to be 90 over x. T2, it's going to be 90 over x plus 30. Not so? So the difference between the two is going to be 30 minutes, which is 30 over 60. Which time is a larger time? The first time or the second time? The first one. Not so? It takes longer with a loaded train. So it's going to be 90 over x minus 90 over x plus 30 equals. The difference between the two is 30 over 60. Or you could have written it as a half. This is number 10. Worked it out already. Yeah. So once you find the LCM, it's going to be 90 times 60 into x plus 30 minus 90 times 60x equals 30x into x plus 30. Once you simplify, multiply all those stories, you get a quadratic equation of 30x squared plus 900x minus 1623 000. Therefore, x works out to be 60 or x works out to be negative 90. Can the train be doing a negative speed? No. So it can't be that one. So what's the question? The question was, what is the initial speed? That is the speed, 60 kilometers per hour. And they want to know the first time, time 1. It's going to be 90 over 60, which is 1.5 hours. Okay? Yes?
What if you did, instead of putting 60,
Sorry?
1 over 2 instead of 30 over 60?
Give the same answer. 1 over 2, yeah? And of course, where you see 60 will be 2. Okay? And this won't be 30, it will just be x. And of course, this here won't be this large, no, not that, but that won't be that large. But once you apply your quadratic formula, you get the same solutions. You get the same. Okay, anything else? Okay, just something I need to explain to you before you leave.
Your attention, please. The cake raffle will be drawn now during break in the quad. The cake raffle will be drawn now during break in the quad, and there will be dodgeball on the field. If anybody is interested, please go down to the field now during break time. Thank you.
Okay, we're just going to look at problems on the rate. There's 2 examples. If you want to leave, you may leave. I know it's break. But if you want to stay, it will be to your benefit. Okay? So if you leave, you can leave now. Okay? Nobody? Okay, fine. This is on page, problems on the rate. It's on page 66. You're looking at example 1 and 2. Yes? You can do whatever you want to, my friend. You must break now. You can leave if you want to leave. But don't leave while I'm explaining now. No? So leave now. Your homework is going to, of course, be exercise 2.18. I think it is, no? Yeah, 2.18. There's 3 or 4, 4 sums. Don't forget, for homework for Monday is the revision exercise. The revision exercise on page 68 and 69. That's for Monday, hand-in assignment, as well as 2.18. Okay, there's 4 sums there. Okay, this doesn't take so long. Right, problems on the rate. This one is example 1 on page 66. So in example 1 on page 66, we are told that Therefore is an experienced plasterer. There's a person who plasters the walls, no? And works on his own. He can, when working on his own, he can plaster a house in 4 days. Simon does not have the same experience, which is less experience than Therefore. And it takes him 7 days to plaster a house of the same size. Okay? How long will it take for both of them if they work together on the same job? So what we need to note here is we can let the variable be we can say let the number of days when working together be X. Let the number when they're working together be X. So if you look at therefore in one day, how much of the job can therefore do in 1 day? In 1 day to finish, if it takes him 4 days to complete a job, then that's meant to say he can complete a quarter of the job in 1 day. Not so. So in 1 day, 3 is equal to a quarter of the job. In 1 day, Simon completes 1/7 of the job. A seventh of the job. Not so. So he's working a bit slower or less experienced than the first person. In 1 day, in 1 day, together, they will finish. If they finish the job together in X amount of days, then in 1 day, they will finish 1/X of the job. Not so? So that means to say, since together they were going to work, so that will simply be, so together, 1/4 in 1/4 over 1/6. So they both finish 1/4, a quarter of the job in a day. Simon completes 1/7 of the job in a day. If you're working together, they complete 1/X of the job. So here it's a matter of solving for X. Of course, your LCM is 7 times 4 is 28. 28x. So therefore 13x is equal to 28. Therefore x is equal to 28 over 11, or 2,45 days. Okay. You okay with that? Let's see if this thing is recording here. Alright. And the last one, just do number 2 quickly. Let's take this off. Is example 2 on page 66. It's very similar. Here we are told that 2 pumps are used to pump water from a river to fill a farm dam. Okay? When operating together, they fill the dam in 15 days. So, working together. Working together. In 1 day, how much do they fill of the dam? 1/50. Not so. Working separately, one pump fills the dam 15 days faster than the other pump. So we say let pump A be X. Okay. So if pump A or the slower pump be X, in 1 day, how much of the dam would pump A fill? Sorry? 1/X. Because if pump A takes X days to fill the dam, okay, then in 1 day it fills 1/X. So if it takes 2 days to fill the dam, in 1 day it will fill 1/2. If it takes 5 days for him to fill the dam, in 1 day it fills 1/5 of the dam. If it takes him X days to fill the dam, it takes him 1/X. In 1 day it fills 1/X of the dam. Okay? Yeah. In 1 day. Then we are told, working separately, one pump fills the dam 15 days faster than the other pump. 5 days. So then pump B, in terms of X, or the second pump B in terms of X would be X minus 5. Why? Because it takes him 5 days less. So if it take pump A 10 days, it will take pump B 5 days. If it take pump A 20 days, it will take pump B 5 days less. So in one day, how much of the dam does pump B fill? 1 over X minus 5. Okay. Find the time taken by each pump to fill the dam if they were working separately. Okay, so in other words, we must work out X and we must work out X minus 5. So remember, when working together, it's 1 over 15. So 1 over 15 equals pump A, which is 1 over X, plus pump B, which is 1 over X minus 5. So that basically gives us X into, we got an LCM of X, 15X into X minus 5. So it's X into X minus 5 equals 15 into X minus 5 plus X into 15. Simplify that, it gives you therefore X squared minus 35X plus 75 is equal to 0. Quadratic formula then gives us X is equal to 32,71 or X is equal to 2,29. Now if you're looking at 2,29, what is 2,29 minus 5? It's going to be a negative value. So this can't happen. Not so. So therefore, it is 32,7. So pump A is going to be 32,71 days on its own. And pump B would simply be X, which is 32,7 minus 5. And 32,7 minus 5 is what? Sorry? 27,7 days. Alright. That makes sense, people? Alright, go through that. And then for homework, I want you guys to do exercise 2.18. We still have one exercise left of exercise 2 of chapter 2, which is inequalities. We'll probably look at that on Monday. People, enjoy the rest of your day. Good morning, class. And enjoy the weekend.